class, for this modules, we're going to talk about radical and rational exponents. So make sure you remember how to convert back and forth of the two forms. Okay, so I want to show you the first problem. You see we have rational exponents right here. Now we want to change it to radical expression. So I just want to remind you that m over n, when you change to radical, the index is going to be the denominator. And then we have m to the n power, a to the n power, I'm sorry. So right here we have the root, and it's the fifth root because of number 5 in the denominator, and we have b squared here. All right, so evaluate. So let's say for a big number, usually I try to memorize the perfect power, but if you can't memorize, you can just go one by one. So you can see that this one, we want to take the fourth root of 256. Obviously, it's not going to be 2 to the fourth, right? Because we know that it's not going to be 3 to the fourth. So what I want to try is, I want to try 4. So what is 4 to the fourth power? That in fact is 256. So the answer is 4. Now the cube root of 125, hopefully you remember it's going to be 5, because why? 5 cubed. 5 cubed is 125. Same thing over here, 4 to the fourth, it's 256. And then right here, so we have -16, and you want to take the fourth root. So what does that mean? You want a number that when you take to the power of 4, you get back to -16, which is impossible because this is not a real number. There's no way you can take any power, any even power number, and you get back to a negative number. But this one right here is -2, because if you take -2, you cube it, you're going to get back to -8. All right, simplify. This is just strictly the exponents rule. So rules of exponents. So we have multiplication. You simply add the fraction. Okay, and then you do the whole LCD. So if I get the LCD plus 1/3, which is multiply 3 here and multiply 4 here. So I ended up with 9 plus 4, which is 13. So what I have is u to the 13 over 12. Okay, moving on for division, same thing. So we have the same rule. It's just right now we have to work with fraction. So sometimes people get a little bit confused when they work with fraction, but that's okay. We just have to deal with the LCD. So in this case, the LCD is 28. So I'm going to multiply 4 here. I'm going to multiply 7 here. So is 12 minus 21 over 28, which is W -9 over 28. Now, hopefully you remember that we're not allowed to have negative, so we're going to have to put it on the bottom. All right. Okay, moving on. This is just a combination. Okay, so I can do everything at once. So I can do, because on top we have product, so it's going to be product rule. So on top I have to add, but then we have adding a negative. So I'm going to write that. And then on the bottom is quotient rule. So we have to subtract the bottom. And then you just work it out LCD again. So I'm going to multiply the first one. So the LCD in this case is 12. So the first one I multiply 6. The second one I multiply 3. And the third one I multiply 4. So what I have is 18 minus 3 minus 4 over 12. Which is 11 over 12. All right, moving on to number 7. So number 7 is simply power rule. So we just multiply the power. So in this case is 6 over 10. Make sure you reduce it. So x to the 3/5. Okay, moving on. Now, see right here, when you're taking the square root, I just want to remind you that we are not allowed to have perfect square as a factor inside. So inside, you want to look for the perfect square in 24. So you're not trying to factor, you're trying to look for a perfect square. So the perfect square in 24 is 4. So 4 times 6 is 24. Now I'm going to take care. So technically this is what we do. So we ended up with 2 square root of 6. All right, so same thing over here. We have 9 as a perfect square. Now for variable, it's really easy. So you take the even number. So we still have 1 left. So we want to break it, and we want to take the even number, because you simply take the power divide by 2, which is the index in here. So I have square root of 9 is 3. So I took care of that. This for this one, like I mentioned, you just take 20 divide by 2, so you get W 10. So I took care of that one. So what we have is 2W inside of the radical. Okay, so same thing over here. We have 4 is a perfect square. I'm just going to put all the perfect square in the parenthesis. So what I have for y is a perfect square, because it's even number, you divide by 2 evenly. Z, we have z to the 4th and z. So z to the 4th is a perfect square. So now we're ready to take it out. Square root of 4 is 2. I took care of that. This one is y cubed. This one is z squared. And then we have 2z right there. Okay. Now, we have to look for the perfect cube this time, because we're taking the cube root. So the perfect cube in 81, hopefully you still remember. So the perfect cube, if you don't remember, you can just simply take 81 divide by the perfect cube. So the first perfect cube I can think of is 8. Obviously it's not working out. So the second perfect cube I can think of is 27. So I'm going to take 81 divide by 27, and I get 3. So 27. Now, y to the 6th power, because 6 is divisible by 3. So what I have is 3. I took care of that. This one, don't forget, you divide by 3 this time. So it's going to be y squared. And then we have 3y. That's the leftover. All right. Speaking of the leftover, That's going to be my trick for these problems. So you see, we have 50 and 8. We need to look for the perfect square. So I will always check out the easy one first. So in my opinion, the easy one would be 8. So I know that 8 is 4 times 2 because 4 is a perfect square. Now what I have is the leftover here. So that leftover is going to help me out with 50. Because we want like radical, and in order for us to have like radical, we need the same radicand inside. So hopefully we have the same leftover. So I'm going to take 50, divide by 2, see if I get a perfect square. And in this case, I do get a perfect square. So I do ended up with a 25 times 2. You see we have 2 and 2. Okay, so don't forget when we're adding, we need like radicals. So what I have is negative 5 square root of 2 plus 4 times 2 square root of 2. Let me simplify one more time. So negative 5 square root of 2 plus 8 square root of 2, which is 3 square root of 2. Okay, and we're done. All right, 98 is a big number. So I wouldn't try to simplify 98. So what I want to simplify, you see we have the 2 right there. Okay, that's the leftover. So I'm going to take 50 divided by 2 and 98 divided by 2. So 98 divided by 2, I get 49, which is a perfect square. $50 divided by 2 is 25, a perfect square. And we have 6 radical 2 here. So now you take 49 out, that's 7. 7 times 3 is 21. So I do skip one step. Hopefully you understand that. Okay. So what I have is 21 minus 5 plus 6. So that's going to be 22 radical 2. Okay. So we're going to do the exact same thing for the next problem. So once again, we're gonna simplify first, okay? And then in this case, between 32 and 50, I actually think 50 is easier to simplify. So I'm just gonna do that first. So 50 is 25 times 2. And then for y, I have y to the 4th and y. Okay, so that's why over here, I'm gonna take 32 divided by 2. In this case, I get 16. 2. So I get 16 times 2, y squared times y. We have to take care of the y as well. So what I have, I'm not going to skip any step this time. So I'm going to take out the 16, the square root 16, that's 4. So cancel that, take out the y for that. So we have 2y. Over here, I have 5, which is that one. And I have y squared, which is this one. So I have 2y for the radical. Now you can see that we have 12y squared, square root of 2y, plus 5y squared, square root of 2y. These two are like radicals, so we're good. So we just simply add. Okay, so for these problems, if you don't have like radicals, something wrong, okay? So make sure you get like radical. So same thing over here. I'm going to pick the easy one. The 7 is the easy one because we have 7 there already. So I'm going to take care of 63. So 63 divided by 7, I got 9. Y v squared. I'm going to put v squared in the parenthesis. 7y to the 4th in parenthesis. And y. Okay. So now let's just take out the 9, which is 3, take out the v. Okay, so I'm going to cross that. We have 7y plus v y squared 7y. All right, so what you have right here is 6y squared v square root of 7y plus y squared v square root of 7y. Like radical, like terms. So what we have is 7y squared v square root of 7y. Okay, very good. Now let's try the higher root, which is cube root in this case. So the cube root in this case, like I said, I'm gonna go with the easy one, and in my opinion, 24 is easier than 81. So 24, if you want to simplify and get the cube root, the perfect cube would be 8, right? And we have 3. So I'm gonna then take 81 and divide by 3. So 81 divided by 3, I ended up with a perfect cube, which is 27. Now we're going to take care of those two. So we have 4 times 3, cube root of 3, minus 2, cube root of 3. This is negative 12, minus 2, which is negative 14. And there we have it. Okay, so for multiplication, even though you can just multiply the radicands and take care of the square root, sometimes I simplify first before I multiply, because if you multiply 48 times 75, you ended up with a big number. But in this case, that big number turned out to be really nice. So if you take 48, you multiply by 75, you ended up with 3,600. And then as you can see, 3,600, and when you take the square root, it's just 60, which is really nice, right? So you can just multiply that. Now, you see that we can recognize the square root of 3,600 right away, but sometimes you can't. So if you want, you can always simplify 48. You want to simplify 75, and then you multiply. All right, so same thing over here. I'm going to multiply first. So I get 10 times 5, which is 50. And then b. So don't forget, when you multiply, you add the exponents. So a lot of people got confused and multiply the exponents. Don't do that. Okay, so as you can see, 50, we take care of 50 a lot. So hopefully by now, you know that 50 is just 25 times 2 and b to the 6th power. That's perfect square. So I ended up with 5 b cubed square root of 2. Okay. All right. Let's try to multiply the monomial by binomial. So you can just distribute. I'm just going to distribute. So I ended up with 6. 5 times 6, 30. minus 6. And then square root of 5 times square root of 5 is just 5. So we have minus 30 like that. And we're done. You can't really simplify 30, square root of 30. So we're done. Okay, so for something like this, we are simply FOIL. Okay, so I'm going to FOIL 4 times 3 12 square root of 12 minus 4 rad 2 plus 6 rad 6 minus 2. Let's simplify. So what I have right here is 12 4 times 3. Okay. So if I take it out, it's going to be 2. 2 times 12 is 24. I can't do anything about 4 radical 2. I can't do anything about that. I can't do anything about that. So we actually done here. We can't combine anything because we don't have like radicals. Okay. Now, when you multiply something like this, for the first one, you know that we have square root of square root of x plus 2 rad 2 like that. Okay. But if you multiply the radical by itself, the radical cancel out. So we ended up with that, and then we have plus 2 radical 2x plus 2 radical 2x, and then the last one is 2 times 2 is 4, and the square root of 2 times square root of 2 is 2. Okay, this is what I'm talking about. 2 times 2. Rad of 2, rad 2. Okay, now we simplify. So what I have is x plus 4 radical 2x plus 8. Okay, now for the second one, this is the conjugate. This is what we have the conjugate. This is what we call the conjugate. So every time you multiply the conjugate, okay, I'm going to remind you. So what we have is a plus b times a minus b is always a squared minus b squared. So that's the conjugate. So now you can see that we can take square root of x squared minus square root of 2 squared. So our final answer is just x minus 2. Okay. All right. When it's come to division, it's actually not division, but it's called rationalize. So before we rationalize, I just want to remind you, so under the radical, we are not allowed to have perfect square. And we're not allowed to have radical on the bottom. So we're not allowed to have radical in the denominator. So what we do is we're going to have to multiply top and bottom by square root of 7, square root of 7. So we ended up with 3 square root of 7 over 7. And we're done. So that's a process of rationalize. Over here, you kind of have to break the fraction first, and then from there, once again, we multiply by square root of 7, square root of 7. So we ended up with square root 14 over 7, and we're done. Okay, same thing over here. You multiply top and bottom by square root of 5. Okay, now for the next one, we can't simply multiply square root of 5 because we have 2 terms. So what we need is we need the conjugate. So we're going to multiply top and bottom by the conjugate. In this case, the conjugate is 7 minus 2 square root of 5. And then from there, I just multiply. So I have I'm going to multiply the bottom first. Okay. The bottom, remember the conjugate. So what we have is 49 minus 2 times 2 is 4. And then we multiply by 5. So on the bottom, what we have is 29. Okay. The reason I want to do this first, so I can see that I can somehow simplify 29 with this factor. But in this case, we can't really simplify, so I know that I can just distribute. So what I have is 35 minus 10 radical 5. Sometimes you get to simplify. So we simplify before we distribute. That's going to be easier for us. So same thing over here, we multiply by the conjugate. In this case is square root of 11 minus square root of 3. Don't forget, we only care about the conjugate of the bottom. So I'm just going to multiply the top, which is 11 minus, if you FOIL, you get 2 square root of 33 plus 3. On the bottom, once again, it's just square root of 11, square root of 11 times square root of 11, which is 11, and then minus 3. Now we simplify. Okay. Now, you can see that 14, 2, and 8 share a common factor. So make sure you simplify it. So I'm going to factor out the 2. So I ended up with 7 square root of 33 over 8. So I can simplify these two. So what we have is 7 minus square root of 33 over 4. And that's the final answer. Okay. All right. Moving on to 27. Once again, I'm going to multiply by the conjugate. Negative 21 radical x plus 7. On the bottom, we have 9 times x minus 1. And as you can see, we can't really simplify anything, so I'm just going to stop here.